Hello from Australia, and thank you to the organisers for hosting this symposium on the mineral nutrition of fruit crops. My name is Sophie Parks, and I am a senior research scientist specialising in plant nutrition. I'm currently working on improving the fertiliser management of blueberry. From this presentation, you'll gain a brief overview of the Australian blueberry industry and the project behind the research and development work we are doing to promote the use of foliar nutrient standards for evergreen crops grown in Australia. Before I go any further, I need to thank my supportive colleagues who work with me on blueberries. Here are Diana and Joshua. They are technical specialists in horticultural research, and Melinda is an extension officer, and she has expertise in blueberry production and, importantly, experience working with the blueberry farming community. Blueberry is a popular fruit in Australia, with over half of households purchasing blueberries on a regular basis. And the production of blueberry in Australia, although small by world standards, has rapidly increased over the last decade to produce around 20,000 tonnes in 2020. Most production occurs in the state of New South Wales on the mid-northern to northern coast, and this is where our research is focused. Here, the summers are warm and humid and the winters are mild, with most production areas subject to a number of winter frosts. In these areas, we use low chill southern highbush and rabbit eye varieties and grow them as evergreen crops. The more southern crops in Australia are northern highbush varieties, and they are grown as deciduous crops. This research is being conducted as part of the Clean Coastal Catchment project, which aims to limit the impact of nutrient pollution from the coast into the adjacent marine estate. Since blueberry production is largely centred around the coast, we are assisting this industry in the development of best management practices for fertiliser use in order to mitigate the risk of nutrient pollution. This includes the use of annual leaf analysis to assess plant nutrient status for guiding fertiliser application. So broadly, our research aims to understand how nutrients, especially nitrogen, cycles through blueberry production systems, and also we aim to better understand plant nutrient requirements within these growing systems. And there are two types of evergreen systems, being a soil system shown on the left and a substrate system shown on the right. Substrate systems supply all nutrients and water through fertigation, and they are being rapidly adopted in Australia. Foliar nutrient standards are used to determine the nutrient status of a crop, and our work on nutrient sufficiency standards for blueberry aims to verify the existing standards within an Australian context. The standards we currently use from Bryson and Mills 2014 are based on 3 varieties of southern highbush grown in Northern America, and until now, no verification work has been conducted in Australia using an Australian variety. So to address this issue, we conducted a survey of foliar nutrients from a widely planted Australian variety of southern highbush called 1111. It's grown as an evergreen crop in the largest production area in Australia. It's an early variety that starts fruiting during our mild winter, with peak production occurring in spring. We've been surveying the leaf nutrients of 4 commercial soil-grown crops in this area on a monthly basis since early 2020. We're interested in the pattern of nutrient concentrations as they relate to the phenological stages of the evergreen blueberry. Also, since January is the recommended period for annual leaf sampling, which corresponds with North American practice, we wanted to see how the survey nutrient concentrations compared with the sufficiency standard values. Our fifth crop in the survey, shown here, was a reference crop growing at our research institute. This is the same 1111 variety as the other surveyed crops, but is grown in a substrate system rather than in soil as for the other crops. The assumption here is that being fertigated daily with a complete nutrient solution, the nutritional needs for this crop would be adequately met, which may not be the case for all the crops in the survey. And here, this graph shows the response of leaf nitrogen from the entire survey, starting in midsummer last year through to summer and early autumn this year. For each of the crops in the survey, leaf nitrogen increases in late winter, peaks in early spring, and rapidly declines into summer. The glaring exception is the Tevan crop in summer, with 2 values of leaf nitrogen being well above those of the other crops. And I'll return to this point later. First, let's look at the associated phonology as leaf nitrogen changes with the seasons. This particular variety is an early variety in that it starts to fruit during our mild winter and peaks in mid-spring. We know from the reference crop at Wollongbar, shown here as the blue solid squares, that during late autumn winter, there is limited uptake of salts from the nutrient solution feed. However, during spring, there is rapid uptake of salts, which is associated with the increase in leaf nitrogen. Whilst the uptake of nutrients is high during summer, there is nonetheless a decline in leaf nitrogen. This perhaps relates to a rapidly expanding canopy or to the allocation of nitrogen to other organs. But further work is required to better understand this process. However, it is quite clear that between autumn and early summer, a strong pattern of leaf nitrogen concentration has emerged, irrespective of the individual crop characteristics. Now let's look at leaf nitrogen with respect to the standard sufficiency range and recommended timing of annual leaf sampling. The optimal nitrogen concentration for southern highbush based on North American data is 1.44 to 1.65%. That is the horizontal shading shown here in the graph. And the recommended sampling period, which corresponds to North American practice, is January, which we've highlighted as vertical shading. Looking at our reference crop values circled in red, leaf nitrogen is close to this sufficiency range. And for this crop, the concentrations close to the January period are more stable than those for early summer or late spring. Based on these data, this period appears to be suitable for annual leaf sampling in this region. However, in contrast, at this time, the commercial Tevan crop greatly exceeds this range for leaf nitrogen. And this departure from the other crops suggests excessive nitrogen supply. We know that this commercial crop is regularly well fertigated, and based on this evidence before us, we would suggest to the grower that he reduce his fertiliser rate or application frequency during summer. And ideally, analysis of nitrogen in the soil solution at regular intervals around this time would assist with refining fertiliser practices. Looking at phosphorus, there was a very similar pattern to nitrogen. However, leaf phosphorus during the recommended sampling periods shows high concentrations of phosphorus for all of the crops relative to the sufficiency standard. It's hard to suggest what may be happening here, and questions are raised, such as, is the phosphorus sufficiency range greater for this variety? Or is the phosphorus fertiliser regime excessive generally for all of the surveyed crops? For potassium, again, similar seasonal patterns occur, and this time the concentration range is within the standard sufficiency range. For calcium, once again, a seasonal pattern occurs, but there is a dramatic drop in concentrations below the sufficiency range during the sampling period. And lastly, magnesium. Given that the well-fed reference crop has a relatively low concentration of both magnesium and calcium, I do wonder if there is a different requirement for these nutrients by this specific variety, or possibly does this reflect a decreased cation uptake due to low pH in the soil or substrate? Rapid soil and substrate acidification is a general concern for the industry here in Australia. So to conclude, although this work has raised a number of interesting questions, we have a better understanding of how the cycle of foliar nutrients in evergreen blueberry occurs. And added to that, January does appear to be a suitable time for leaf analysis, since this period does coincide with a steady nutrient concentration range following harvest. We aim to embark soon on experimental work to get a better understanding of nitrogen demand in the context of these evergreen cropping systems. And I look forward to sharing these results with you in the future. You've been a great audience, and thanks for listening.